Ladies and gentlemen, welcome to a very special edition of Oppenheimer Ranch Project interviews. And we have Mark Carlotto, the author of two books, Before Atlantis. And what's your other book, Mark?
It's called Beyond Atlantis.
Two excellent publications. Now, Mark is no slouch. He's an aerospace engineer with over 30 years of experience in satellite imaging, remote sensing, signal and image processing, pattern recognition, and application development. He received a PhD in electrical engineering from Carnegie Mellon in 1981 and has published hundreds of technical articles. He has an amazing paper we're going to discuss today, a new theory of Earth's crustal displacement. And like we just said, Before Atlantis and Beyond Atlantis are his two books. So it is a pleasure to have you on the show, Mark. Welcome.
Thanks, Diamond. Nice to be here.
Now tell us, what I didn't glean from all this information is what tickled your fancy about ancient megalithic structures and some of the more esoteric science, catastrophism. In this case, we're going to be talking about the ideas of Hapgood and Chan Thomas, crustal slip or crustal displacement. What made you get interested?
To go back to the 80s, I actually was involved in the Face on Mars controversy, which you may or may not be familiar with. And there were people interested in alignments on Mars. And at that time, I actually wasn't particularly interested in the idea. I was more interested in sort of determining if the structures were artificial. But, you know, certain things, certain work was done. And it was many years later, I'm looking at Google Earth images of sites I hope to visit in Mexico to go on vacation. And I noticed they're not aligned to north. And I remembered, you know, learning about or hearing about Hapgood's theory and just a lot of things. I started thinking about a lot of things. And it was like, I wonder if these structures are aligned to where the North Pole might have been. And using Google Earth and, the ruler tool, and, getting a little obsessive over the first couple of months, discovering hundreds of alignments that of sites, not only in Mexico, but, I was looking at other parts of the world. It was like, it just blew me away. It's like, wait, all these sites that are not aligned to cardinal directions, and doing a little research, finding there weren't any really good, really compelling explanations, finding that they seem to reference, at least a couple of possibly prior locations of the North Pole. Really just, it's like, wow, has anyone not looked at this? And so it just kind of, it just sort of infected me. And that was 5 years ago. And, I just completed Beyond Atlantis, where I found now over 500 sites that appear to reference over 1,000 sites that reference the current and 4 previous locations of the pole. About 500 of them reference prior locations. So it's like not one or two, but literally hundreds throughout the world.
Yeah. Now, the big problem with your discoveries and anyone talking about this topic is that we are immediately discounted as conspiracy theorists or pseudoscientists. Now,
Right.
The problem all goes back to the inception of geology. And the group that was creating this science decided, and this is over a century ago, that we were going to go with the law of uniformitarianism. Now, this is the idea that the Earth has always changed in uniform ways, and that the present is the key to the past. Now, when I was told this in the beginning of my academic career as a geologist, it didn't stick well. And I was like, well, what if we're wrong and things were different in the past, like dinosaurs? You just throw out that thing, like dinosaurs can't exist on Earth today based on gravity and everything. So clearly the past must have been different. So I think the whole field of geology has been stuck for 100 years. Now, I was a catastrophist. I studied the Milankovitch cycles. My graduate work was going out in the field and locating cycles that were in this nested hierarchy, showing patterns of catastrophe that have been going on and on and on throughout the entire history of Earth's geologic career. So something is clearly happening in a regular pattern, catastrophically, and it's easily provable. Now, what you're doing is not real big picture. You're looking at the more recent structures and extrapolating that, yes, maybe something is going on here.
Mhm. Right. And, you mentioned Milankovitch, and we'll talk about him more, I assume, in a bit. But, he was one of the early proponents of a process that sort of went along with plate tectonics, called continental drift at the time. When Wegener was developing his theory early on, Milankovitch believed that there was another process going on where that the entire crust would reorient itself to maintain the Earth in a state of equilibrium. And so, but this was sort of a minority point of view that I think, once plate tectonics was sort of proven, if you will, in the 60s using paleomagnetic data, I think, people or geologists were happy with just plate motion and they didn't care about anything else. But even early on, there was this notion that the crust would, there would be some other, another degree of freedom. There was something else going on to maintain sort of the whole crust in a state of equilibrium.
Yeah, and that's hard to do. In fact, Leah and I were just having this discussion last night that what I find fascinating about the science is that when plate tectonic theory emerged, it was simply from moving a magnet across the Atlantic basin. They noticed that the mid-ocean ridge showed a mirror copy of the same magnetic flips. And they said, well, it appears as if the mid-ocean ridges are spreading at equal rates. And then they concluded that that must mean that subduction zones are subducting at the same rate. Mm-hmm. None of that has ever been proven. So it's my supposition based on the paleo environmental data, the whole idea, the concept of Gondwana or Pangea, is that the Earth has not been the same size and it was much smaller, and that mid-ocean ridges are driving the expansion of the Earth, and that subduction zones do exist, but they're not subducting at the same rate that the mid-ocean ridges are growing. And this, again, shows that the crust can move independently, and maybe during periods of large mid-ocean ridge activity, that's when we get the quote-unquote crustal slip, which would be more similar to polar wander, that idea in some peer-reviewed papers, that show the direction of like the Hawaiian island arcs changing 40 million years ago.
Yeah, and and I think this is why what I'm proposing here is viewed as fringe science, pseudoscience, because geologists say there's no evidence of a rapid displacement, and that the current model is the slow polar wander, which is pretty well established. All I'm suggesting is that over this small polar wander, there are these periodic shifts that occur, and they occur at over a time scale that's really too short to be measured using paleomagnetic techniques, right? Because when you're using radiometrically dated rock, with an uncertainty of 500,000 years or and at that scale, changes that are occurring every couple thousand years are happening too quickly, and you're not going to be able to measure them. And I think that's one reason why that maybe this has sort of fallen through the cracks, and it hasn't been picked up in the geological record. And I talk about some of the problems with it in the paper at the end. But again, I'm not advancing this as a theory in itself. I am trying to find a possible mechanism to explain crustal displacement. I'm not coming at it as a geologist. This is not a pet theory of mine. I'm just kind of putting it out there as a trial balloon. I've encouraged people, hey, if you have more specialized knowledge, please, I'm happy for you to get involved, because it's not the sort of thing that I really do. When I set out and I wrote a couple of papers on this whole model of how archaeological sites are aligned. The current model being, we align them to the pole and to the moon and to the sun, and perhaps to the stars to some extent, and some other there's some other criteria as well. but largely, I simplified it. Let's say the sun and the moon. And I came up with a model, and I showed, about half the sites on the planet could be explained this way. The other half had no explanation. So my quest is to sort of figure that out. And in the process, if your proposal is, well, it was a crustal displacement, so people start asking you, well, how could that happen? And I was waiting for someone to come up with a theory. It was a couple of years and no one's coming up with a theory. So it's like, damn it, I'm just going to do it myself. So, I mean, it's never stopped me, damn the torpedoes, full speed ahead. So anyway, so that was the origin of this paper, a couple of years ago, where, I approached it kind of as an electrical engineer. I looked at this whole question of insulation, and these climate proxies, and why don't, they're kind of correlated, but they don't really line up perfectly. One lags or leads the other, and there's, you squint your eyes and there's certain correlations, but they're not the same thing. Specifically, let's look at ocean at sea level over the last 100,000 years and look at insulation. And so what I decided to do is like, okay, I'm an electrical engineer, so what I know how to do is I know how to create what's called a linear predictor, which says, let's look at all the data and try to fit a linear model to it. And then using that linear model, let's try to predict one variable using another. And when you do that, you get an approximation to what sea level should look like if it was modulated based on just insulation alone, and you get a difference. And I don't know if you can scroll down on the website. Can we have graphics?
Yeah, let me share the screen.
Because I'm gonna let you draw. You want me to do it?
No, I'm gonna do it. It's gonna take a second here. Boom. All right. All right, here. Great. Let's go here.
So just go down. Okay, and so right there, let's look at that for just a minute. These are, I've got it here too. So this is the average daily mean temperature, top of the atmosphere. I'm sorry, average daily mean top of the atmosphere insolation, and global sea level. And so these are, you can see there's some correlation between the two, but it's not exact. And so, climate scientists are saying, well, it's the sun, it's insolation that drives climate. So what I did was, if you scroll down, I said, okay, let's use one to predict the other. Let's try to predict sea level using insolation. And if you do that, you get this curve, that dotted line there, which, kind of gets the, you got the undulations, the modulations, but there's an increasing deviation as you go from 130,000 years ago to, its maximum around 20,000 years ago. If you subtract the two, go down a little further, you get, yeah, there we go. Yeah, that's the one. If you subtract the two, you get this, and this is a difference. This is a sea level difference plot, and it plots the difference between what insolation predicts and what it doesn't. So this is sort of like the missing. This is the missing link. And if you look at it, because sea level is inversely related to the amount of polar ice, so as polar ice grows, sea levels drop. You see that as ice accumulates to the right there, as we go from 130,000 years towards the LGM, sea levels continue to fall as ice continues to accumulate. And then about 20,000 years ago, it shoots up. Something melts the ice, and we're at at current levels now. So what you can then do is say, and this is in the paper. It's actually not on this blog. This blog was technical enough, and the lack of readers is testament to that. It's like the more complicated stuff I post, the fewer people read it. Anyway,
well, can I just comment on this real quick?
Yeah.
So I think, this is where in the main scheme of things, over the last several 100,000 years, this is one of the few places where insulation deviates from sea level. For the most part, it matches and it just lags behind. But
Yeah.
then you get to this period about 50,000 years ago to the end of the Younger Dryas where it deviates. Now, according to the work that Lee and I have done, during this time period, there were at least 4 cometary encounters with our sun and impacts on Earth. So what you're going to have is more cooling effects, more catastrophic events that are going to deviate insulation from sea level, in my opinion. So there could be external things happening here to create the deviation.
Yeah, I mean that's I hadn't. I'm not familiar with that, and to be honest with you, I did the linear regression over 2 glacial cycles, but I don't have that here. There is some deviation, and as I recall, it's not as great. But I mean, in the nature of statistical, fits, there's always nothing's ever going to fit exactly. But I mean, that's certainly, hey, that's plausible. I'm not going to get religious about any of this. It's certainly possible.
Yeah, because it seems like here around 150, there's a major deviation, and then
Yeah.
this deviation we just looked at. But the internal times here has more of a better smooth match. Do you agree with that?
Yeah, but the other thing that's a little hard to understand too is sometimes it lags and other times it leads. So it's like the cause and effect isn't always doesn't always seem to be in the same direction. I'm not the one that's noticed that. There's people have talked about the problems with insulation as a model in itself. And so I mean you're touching on an extraterrestrial cause. And
Yeah. The big question that we've been trying to answer is looking at this graph. What drives that 104,000 year cycle? Because there's a 100,000 year glacial cycle with obvious major perturbations in between. And if you look at insulation, if you look at Milankovitch, it's close, like you said. And this is the conundrum for decades that I've been struggling with. What is driving this? Because clearly it's something that is pervasive, external. It's external. It's not the Earth.
Yeah.
And we just can't get it. There's so many variables.
That's what I was about to say. There's so many different variables involved in this, and I think it is really important to explore all of the elements, including, crustal slip ideas. Like, I think that should definitely be explored. But then you've got, the potential for solar outbursts. You've got the potential for impactors from comets and asteroids and airbursts. You've got, something that we've noticed is like there seems to be like an electric circuit, and this comes out of electric universe theory stuff that may be playing a role here. But what is the agential cause? Like, what is the trigger? And there are many different things interplaying here, and it's a little hard to tease apart, partially because of what you said. There are changes in terms of what's leading and what's lagging in the variables. So it's a little difficult to tease apart. And I think your paper actually demonstrates that quite well, because you sort of bring in a lot of the different ways of looking at this, the different models, and it becomes a little hard. It becomes hard to isolate one variable over another.
I mean, the answer might be that it's more than one thing.
Absolutely.
But what's fascinating. Yeah, but what's fascinating about this is that it's sort of periodic, it's sort of regular, but not exact.
Mm-hmm.
And so there's some cyclical thing going on, whether it's a swarm of extraterrestrial bodies in some orbit. But even if that were the case, you would expect it to be even more regular than this. I don't know. It's again, it's a little bit outside of my wheelhouse. But what I attempted to do then next is, if we could just to sort of take this maybe to its chronological completion, why I believe a pole shift model may be worth looking into a little further, is that, as at least the sort of the heuristic I have is that ice accumulates much more readily on land than it does on water. And so what I looked at then were the land areas under the polar regions in these hypothetical poles. So I kind of already had the poles at this point identified. So I looked at the land areas and I made some allowance for sea levels being, you know, a little lower and so forth. I did a plotting the land area versus the sea level. And so, you know, if the sea level is related to the amount of ice, then the two should be correlated. And this is actually in the paper.
Okay. There.
Yeah, yeah, you can actually click on the paper, right? So if you go down to, keep going to right there.
This figure 5?
Yeah, relation between sea level and land areas at former poles. And so it's, you know, it's not a perfect linear model, but, you know, it's an R squared with a 0.7. So that's a correlation coefficient of, what is that, like 8.85, something like that, which is that's a pretty strong correlation. So this hypothesis is, you know, I would say supported by at least the geography, that, you know, if the crust and the land masses were similar to what they are today, and you buy that the sea level, and this is a valid model to explain sea level change, that the sea level data are accurate, then I think it sort of hangs together. Again, the caveat is over the last 100,000 years. Now going back, you know, 2.5 million years, you know, I haven't done that. My interest in the last 100,000 years is that this is the sort of the time frame of these archaeological sites that I'm looking at, and that, you know, my hypothesis is that these sites, the earliest sites, were established not, you know, 1,000 or a couple thousand years ago, but tens of thousands of years ago, over, you know, within this period of time. So that's why I'm interested in this period of time. Obviously, you got to, if this is, you know, if you want to explore this as a theory, as a hypothesis in a broader sense, you got to go beyond that, like, you know, like you suggested.
So let's bring people up to speed on what we're talking about here. This is the only simulation you can find on crustal displacement. And what it shows is the rotational pole of Earth very clearly, and that at some point you'll see the crust stops rotating with the Earth. And what then is happening is the mantle is sliding by the crust. And this is Hapgood's model, that the ice then drives the crust towards the equator because it's off balance.
Right.
And so this is the most extreme theory of crustal displacement, where the entire shell slides. Now, there's a couple problems with that. And you don't like this idea at all, because your pole is staying up near the Arctic Circle. So the crustal slip is going to be less extreme in your version.
Much less.
Yeah, much less. And you know, it must have been difficult for Hapgood. He had this great monograph assembled. He's publishing this book in, I think it was 56 or 58, and he asked Albert Einstein to review it. And Einstein says, "Yeah, it's an interesting theory, but I don't think the weight of the ice is enough to cause this to happen."
Yeah, and there's lots of problems with Hapgood. He presents the Pura-Reis map as a ice-free Antarctica, but anyone can clearly go look at the Pura-Reis map and see that what it's showing is the southern tip of South America. It even has all of the coast, the inlets and the cities, everything there, even the animals that lived in the southern tip of South America. So it was not an ice-free Antarctica that he purported. Additionally, I'm sure you're familiar with this. This is World in Peril.
Yeah.
This is also based on bad geology and just bad ideas that have all been discounted since the writing. You know, they claim that in the Arctic they found coral and tropical plants. Yeah, they are up there, but they're Carboniferous. They're 140 million years old. Yeah. They're not recent.
Right.
Yeah.
And this is a mistake a lot of people make, and because the whole time scales are off. oftentimes.
Yeah.
So yeah, so the main problem with Hapgood was that the ice could be the driving mechanism. And so what I did, it's an appendix in the paper. What I did was I used a model of the crust. It's the Crust 1.0, which is a publicly available database that's you can use in a finite element model to, well, I used it to compute the moments of inertia of the crust with and without ice. And I used the last glacial max ice sheet, and I made some approximations about its thickness and its extent. And it turns out that where is it? Oh, there you got it right there. That the difference in the moments of inertia in what's called the theoretical rotational axis differ only by about 20 kilometers. So all this ice that was up there, yeah, it would have changed the moment of inertia of the crust, but it was a very small change. I mean, the crust is big, and there was a lot of ice, but the crust the crust is big, and orders of magnitude difference in mass. So so using this crust model, I did this experiment, and it's proves shows Hapgood is wrong based on using this analytical model. Einstein knew it instinctively, intuitively, almost 100 years ago or 80 years ago. But
his name is prominently shown on the book, and everyone says, "Oh yeah, it's correct."
That's right. That's right.
Mark, I have a question about
Yeah.
this, the theoretical rotational axis for you. Diamond, maybe you could scroll down more to show the comparison with other TRAs.
That's the end. No, it's up here.
Oh, where is that? You've got several images of,
here right there.
So why, for these different theoretical rotational axes diagrams here, why are the relative positions of the continents different?
Oh, okay. So what this shows, Leah, is the red dot is the TRA,
Mm-hmm.
and what I'm doing is I'm plotting it in different worldviews with different north poles.
Mm-hmm.
So the top one is I think its top one is Hudson Bay, then Norway Sea, then Greenland, then Bering Sea. And what I'm in this part of the discussion, what I'm talking about is what actually I rediscovered. It's actually in the literature that the TRA, the theoretical rotational axis of the crust, is not lined up with the rotational axis of the whole Earth, but is actually near the equator. And so, in other words, the crust is not in equilibrium with the rest of the Earth, which is weird. Why would that be? Why would the crust not be in equilibrium? So what I talk about here is this, and I'm getting a little ahead of the discussion, but the idea that the pull of the moon could be the force that's actually responsible for the displacement. And actually the pull of the moon and the sun, in other words, things moving in the along the ecliptic. So the ecliptic, is roughly defined. The projection will lie within the tropics, between the Tropic of Capricorn and of Cancer, and that's what those dotted lines are. So what I'm showing here is that if the moon did pull on the Earth, shifted the crust, the TRA kind of remained in this region, even though the poles are moving. It's moving in such a way that the TRA remains in this region, which is where the force of the sun and moon are acting. Again, it's sort of a qualitative heuristic kind of argument, but I was just trying to show that it's plausible. That's not implausible that the moon could be pulling, the sun and moon could be pulling on the crust.
So would the result of a TRA calculation, would that require that the continents be in these positions that are different than what we see now? And how are those positions determined, I guess is what I'm asking.
Oh yeah, no, I mean the TRA that I computed was relative to the current North Pole, and if the crust moves as a whole, then it doesn't matter. It would be rotationally invariant.
Yeah, I think the question is that it seems like South America here on your final map has rotated 90 degrees.
Oh yeah, it has because the pole is different. So this is a what projection is this? This is one of those weird equal.
So it's a weird projection and it just looks weird.
Yeah.
Yeah. Okay.
Oh, okay.
Yeah, because you can't, there's no way in the last 100,000 years you're going to rotate South America 90 degrees relative to North America.
Right. Or if
Yeah.
you look at South America relative to Africa, those angles are entirely
Oh yeah,
different.
yeah. I'm sorry. Yeah, I'm sorry I missed that. No, the continents aren't moving relative to each other. I mean, if you looked at this on a globe in Google Earth, it's just shifting the pole location.
Right.
But it's distorted when you project it to.
Oh, okay. Fair enough. Because I was looking at this and I'm going, now I'm really confused because we've got a whole nother series of variables in here.
Oh yeah, no, it's complicated enough. No.
Yeah.
Yeah, so the pole is basically just migrating up around the Arctic Circle, around 20 degrees south. In that circle where the aurora belt is, let's say, that's where the pole is migrating.
Yeah, because the sun moon is acting on the Earth within the zone of the tropics, which is again not just the equator, but it's a range, and so it's pulling and it's moving the crust, it's displacing it relative to where it was. So it's kind of what I'm trying to do is kind of like it's sort of like a back of the envelope, rough order of magnitude kind of argument.
All right. So, and your argument is, let's see if I could pull it up. I know I have something here, is that the geomagnetic field intensity, and this is a great paper. I don't know if you know this paper, the role of geomagnetic field intensity in late quaternary evolution of humans and large mammals. It's some of the best paleogeography, stratigraphy, and geomagnetism all brought together in one piece. And it has some of the highest resolution field strength graphs that go back 300,000 years.
Yeah, I've seen it. Don't test me on it, but I've seen it. And I think that may have been one of the sources. I think I had several sources. I identified, I think it was 5 geomagnetic excursions over the last 100,000 years. I think some of them are in that paper and some are in others, but it does look familiar.
Yeah. Now, the issues with determining the age of these geomagnetic excursions is that over the last decade or so, different volcanic events have been studied and the positions of them have shifted. Like Mono Lake was once thought to be earlier, and then it's placed later, and Pringle Falls has moved around. But what I want to draw your attention to is the fact that the Gothenburg magnetic excursion, which is assumed to be around 12 and being associated with the Younger Dryas event, it actually goes on until 8,000 years ago. There are 3 events during a 5,000 year period where the field strength is extremely low. So there's actually 3 magnetic excursions within the Gothenburg excursion itself. The only significant magnetic excursion for quite some time has been the Lechamp.
Yeah.
And this caused a massive mass extinction on Earth. It was the end of Neanderthal. And new papers coming out are showing that the UVB radiation may have been so high that a lot of the biome died off. So what's happening on these excursions is terrible for people on the Earth, but it may also be affecting the connection between the crust and the mantle. And that's the assumption.
So, yeah. So again, working backwards, I had established, and if we go down to, we may want to go back to this, but if we could go back to, go down to, there's a figure that shows some curves and pole locations right there. Yeah, right there, and blow that up.
Boom.
There we go. And that's I'm looking at this in the paper. It's correct. Somehow the Toba eruption is the Tomba eruption.
Yeah, I saw that when you were on Leak Project, and I was like, he's got a typo there.
I know, but it's actually not. It's not on the paper. It's like, oh, thank God it's not on the paper, and it's not in the book. It's just on the website, so it's okay. What I noticed was that more, and you're talking about changing the timing on these, and when I'm saying they're correlated, I mean this is again rough order of magnitude. There was a geomagnetic excursion around 120,000 years ago called the Blake, this is around the time that we hypothesized the pole shifted from Bering Sea to Greenland. There was another one, Norway. It was called Norway Greenland, that preceded or occurred around the time of the Greenland to Norway sea pole shift. And then soon after that is the Toba eruption, which is a VEI8 event. It was a huge event, mass extinction, even more so, right, than Lachamp.
Yeah.
And then
that was the predicted bottleneck where there could have been as little as a few thousand humans left.
Yeah. So I mean, clearly that there was something big happened then.
And interesting to note, Mark, is that the Gothenburg and the Younger Dryas impact event at 12.9 is preceded by the Locker Sea, which is a massive volcanic event that many people thought was the driving force of the Younger Dryas event, but it happens to be a few hundred years before the Younger Dryas event. So you have another massive volcanic event during the Gothenburg.
Yeah, and it gets there's obviously some strong correlations, and I'm sort of suggesting some causation here, but it's certainly not proven. I'm just suggesting that there may be things that are happening sort of around the same time that we should look at, because they're interesting. Anyway, so yeah, I'm not sure we want to talk more about this, other than to say that the timing supports some of these pole shifts better than others. There's some uncertainty. I kind of take the pole shifting from Hudson Bay to the Arctic around the LGM because that explains the melting the ice. But you don't find any large volcanic event, I don't believe, at around 20,000. And the geomagnetic excursions are happening before and after that. So there's not necessarily a clear cause and effect on all of these, admittedly.
Yeah, well, again, I think we are potentially dealing with a lot of different variables. I mean, Diamond and I have discussed a lot of different variables, for example, at the Younger Dryas event. And we still seem to be missing some, perhaps, because the line of causation is not entirely clear.
Yeah, the Younger Dryas event is unique in the last 400 or so thousand years. It is unrelated to what the large-scale driving mechanism of ice ages are. For some reason, we were coming back up into the next interstadial during the Bowling Allerod, and it got cold again. So clearly there's another catastrophe that is causing a 1,500-year blip from the warming.
Yeah.
Right, yeah. But even at the Bowling Allerod, right, it's really not clear what caused that large temperature spike.
Well, it would be a pole shift, but that would have to have happened around 14.7 is when the warming begins.
Right.
Yeah, I mean, and that's possible. I don't know how. The global sea level data is obtained by averaging a couple of different measurements, and so there's uncertainty in all of this.
Yeah, indeed.
So.
All right, where do we go?
So the mechanism that I'm proposing is maybe a little simple-minded, but someone said, keep it simple, stupid. So I'm going to start simple, and if it's too simple, then maybe someone will come up with something else. But the idea that I thought of was if we could scroll, let's see, I think scroll back up to there. So, we're not talking about a geomagnetic reversal that's permanent. To the extent that the ones millions, hundreds of millions of years ago. We're talking about excursions that last 100 or 1,000 years that are much shorter duration, and they may not even involve necessarily a complete reversal of the pole. It may be a weakening the field, or there's a whole range. When they talk about excursions, it's much fuzzier. Reversals are clear, but excursions are less clear. But the general idea is that if, and this is, so I'm going to simplify it. If the core field suddenly reversed itself, the crust has is ferromagnetic, so it's got a magnetic field. I don't know what that is. I don't know the magnitude of that. It would be great if someone did. Maybe there are people that know this kind of stuff, and we can tease them out of the woodwork with this show, hopefully. But if the pole flipped, and you got the very simple idea now of a North Pole and a North Pole, and the idea now is that the crust would not necessarily have the same connection to the mantle that it has if the magnetic field were reversed. It would be reduced by some amount. I don't know what that is. If it's reduced enough, then the forces that are always pulling on the Earth, namely the moon and the sun that move the oceans, which is not a small feat. And by the way, it's always pulling on the crust because and the work that does creates heat, and it's dissipated. But if the crust now were free to move, if the crust were not locked to the mantle, and it could move very slowly, my suggestion is the possibility that the moon begins to start to torque the Earth, within this band, we looked at in the earlier graphic along the tropics, and can actually begin to slowly displace the crust over the mantle. So it's not a catastrophic pole shift scenario. It would happen over months, years, tens of years, hundreds of years. I don't know. Again, I don't know the magnitude of the amount of friction and the degree to which that would be, relaxed by reversing the magnetic field or reducing the attraction between the crust and the mantle. But if it were less,
one consideration that I was talking to Lee about last night is that the surface of the crust has a topography. We've got a continental crust that goes up miles above sea level. And then we've got the ocean crust, which is much thinner, averaging 20 to 30 kilometers in thickness. That's more average, except when you get to mid-ocean ridges and seamounts. That same topography that's vertical is also in the negative. So where you get continental crust meeting ocean crust at subduction zones, you're going to have huge drop downs in the crust into the mantle. And in order to get the whole skin to slide, you're going to have a huge amounts of reverse topography that's preventing that from happening.
Mm.
But what is really interesting about this is, okay, you discussed in the paper, so magnetic excursion starts, right, and then that triggers this oppositeness in polarity between the mantle and the crust that would unlock it. And like you already said, and I was saying the same thing last night, we really need to be able to do a calculation of the magnitude of those forces versus the tidal forces and whatever else is going on to really know if that would work. But perhaps that is playing, because even if the whole crust is not slipping, it is still slipping in some sense, right? Because we do have plates moving. So perhaps the magnetics, the change in magnetics is playing a role in the plates moving.
Yeah, it might not be one or the other. It might be a combination of the two.
Right.
Or I have a third idea. The area of the Mohorovic discontinuity is a zone in the mantle.
Mm.
A plastic zone. That's the way it's taught in the literature.
Yeah.
What if that whole zone has a certain resistivity or change in magnetism that makes it more fluid? Then you would get a huge region that could easily, the crust could slowly creep, well, faster than it normally does, into a new position until it changes.
Yeah.
And as far as the magnetism of the Earth's crust, there are papers on the resistivity of the crust that you just got to go out and get them.
Yeah.
One
Again,
other thing I want to bring up, sorry, that
okay.
Diamond was talking about last night, because, and I think this really has to be considered, is just the fact that the Earth is not a perfect sphere, right? It's a little oblate, right? So there is kind of an issue here with the whole crust slipping. As the analogy he used is, as if the Earth was shaped like an egg. I mean, it's not that extreme. Trying to get the shell to slip over the inside of the egg when it's shaped like that does present a problem. Unless it's extremely slow, or unless it's sort of happening piecemeal, like by plate by plate.
Yeah, and I think that it would be a bigger problem if we were claiming that the rotation was 90 degrees. The fact that that's staying within the polar zone is not as bad as that as it could be.
Agreed.
Yeah. That's why we like your paper, Mark.
So I mean, I think we jumped around a little bit, but I think those are the takeaways from the paper. And so there's some ideas out there. I feel like the first part of the paper where I kind of established the case for insulation being part of the driving mechanism, but there being sort of this other nonlinear term, that I feel that's a fairly strong result. Now, what that means, I'm interpreting it, of course, in a pole shift context, which I can justify using this, correlating sea ice and land areas. But you propose another explanation that's also plausible. But then once you get beyond that to the mechanisms, it's an idea. It's not ice anymore. So hopefully we can start talking about Hapgood 2.0, because I think. If it wasn't for the way that pole shifts explain climate change, ice ages in an extraordinary way, and my experience in how they explain the alignment of archaeological sites, I mean, because a lot of times I'll be thinking to myself, this is a crazy idea. I don't want to be one of these crazy, pseudoscientists. I mean, I'm still working. I have a reputation. So I don't want to completely, go off the deep end, but it's like, damn it, but it may be impossible, but I think it was Sherlock Holmes. It's like, after you eliminate everything, no matter how improbable, it's even, the impossible, it could be the only explanation. And I really butchered that, but the bottom line is, you get to the point where it's like, well, what else could it be? So that's why I kind of pushed this, at least the beginnings of trying to come up with a theory a little bit further, that I hope others will join in and have, join the party.
Well, good for you for stepping out of the box a bit. Many years ago, I worked for an organization called the Chemical Heritage Foundation. It's now called the Science History Institute. And I worked on a project, a book editing project about the Gordon Research Conferences, if you're familiar at all.
Yeah.
And the beauty of those conferences, right, is that you literally have a group of scientists that are tucked away for a couple of weeks, and everything's off the record, and they get to talk about whatever crazy theories they might have, and work interdisciplinary. I can't say that word right now. Work on an interdisciplinary basis with scientists, discuss all of the crazy theories, put it all out there, and not be worried about their reputations. And I think it's kind of a shame that we have to go to such lengths to have those conversations. But I think it's even more important that scientists are brave and are willing to step out of the box a little bit, despite whatever ridicule they may endure from people whose thinking is really dogmatic.
I guess I have no shame. I don't know. Life is too short, I mean, these are. It's just striking. I think even over the last, I've been doing this for a while in my profession, and ideas have just gotten so much more conventional, and people are not as I don't know, as able or willing to kind of go outside the box and propose new stuff. But I think science is so stagnant. I mean, is what's exciting nowadays? It's Musk's vision of going to Mars. Fortunately, we still have that, but I think there's so much to be discovered. But there doesn't seem to be a lot of excitement in science to do that, because scientists tell you, well, they got everything all figured out. They know how the Earth works. They know how the human body. They know consciousness. It's like just it's just statistical AI, and
Well, it goes right back to the issue with uniformitarianism that Diamond brought up in the beginning of this show. We discuss this again and again and again because it keeps coming up. It's not just in geology; it's in climate science. We pretend that things are always as they have been, which is just not the case, and we already know that from our history. Like, why did we have a major ice age? Then clearly things are not always the same, and it's very much hampered by this desire to stay in line with a particular narrative and not being willing to step outside the box and take those risks.
Right. I mean, I think perhaps in more of a meta sense, things may be uniform, but in other words, life has changed, the universe has changed. Maybe the rules of change are immutable and constant, but given those parameters, within that parameter space, lots of things go on that if you can step back and see what the sort of the meta ideas, the meta theory is, it sort of makes sense. It's sort of like, there's catastrophes and there's pole shifts or whatever, but these occur within a theoretical sort of framework, an understanding that is somewhat constant at a higher level. I'm getting philosophical, which is I'm babbling. I apologize.
Oh, no, I'm all over it. My background is in philosophy of science, so I'm all over it myself.
Okay, good.
I like to point out that the law of uniformitarianism is incorrect.
Yes.
And an obvious thing is, if we just travel back in time 200 years ago, if you were alive from 1811 to 1815, you would live through multiple New Madrid earthquakes, which destroyed most of Central North America. And then by 1815, it's boom time. We have a VEI 7 volcanic eruption, which darkens the skies for 3 years. That is recent in history. Everyone's forgotten about it. I wasn't warned in high school that a giant volcano could erupt at any time and make it for years. If that were to happen, and it will, not this year, maybe, hopefully not next year, but it's going to happen, that's when humanity gets slapped in the face and they're like, it's not always the same.
Yeah.
Like Mark said, there is a overall set of rules that we haven't figured out, or so it seems, and I think that's evidenced by the cyclical nature of all of this. The catastrophes are cyclical. There's and we go through this again and again.
Yeah.
Well, is there any projects you're working on you want to shout out to our listeners?
So, this paper was published last summer, and so I was writing it like a year and a half ago, and so I kind of like had to go and look at it this morning. It's like, well, what is this paper about anyway? I kind of forgot a little bit because I just published this, which is Beyond Atlantis. So there was this, which you showed, Before Atlantis. And then Before Atlantis, I wrote that and published that in 2018. That sort of goes through the process of discovering these ancient poles, and that so many, evidently, a lot of archaeological sites aligned to them. And it was sort of the starting point. And what I do in Beyond Atlantis, in this book that I just published around the holidays this year, is to show that they actually fit into a context, into prehistorical context. Because initially it was like, site here, site there. There were sort of just almost, there were a lot of them, but it was like there was no context for understanding, well, how could this be? And what I do in Beyond Atlantis is I have 20 chapters, and I go in different parts of the world, and I look at the earliest civilizations there. And look at the stories and the sites. There's a lot of graphics and pictures. And I look at the alignments of these sites, and I show that in most cases they can't be explained in terms of current alignments to the sun or the moon. But when we shift our reference point, we look at Hudson Bay, Norwegian Sea, Greenland, Bering Sea's prior pole locations. Then many of these sites, the vast majority, in fact, are explainable, either aligned to the sun directly in a cardinal sense, like Mario does. But what I also show is that alignments to the moon and solstices are also, in fact, even more common. Perhaps because from an observational point of view, when you think about it, it's much easier to mark the extreme motion of the sun and moon than the equinox. It takes a little bit of technology to be able to do that. The Egyptians were able to do it, but primitive people might only have been able to mark the extremes. The furthest north, furthest south, the sun travels during the course of the year, for example, to mark the solstices. And anyway, so Beyond Atlantis, I tie a lot of this to early civilizations in different parts of the world. So I have a prehistorical context. It's not like just kind of hanging out there on its own as kind of some wacky theory. But what I'm trying to do is using myth and legend and old stories to try to sort of using them as breadcrumbs to try to fill in with this new theory how stuff might have been over the last 100,000 years. And my hypothesis is that there's been at least, four previous civilizations or activities on this planet that were building sites in alignments or in directions that reference previous poles for whatever reason. And that what exists in these places today are built over earlier sites. And we find this in many places. We find, Rome was built over, Roman ruins were built over even earlier ruins, Etruscan or even earlier ruins. The Parthenon in Athens is built over an earlier Parthenon. The Roman temple at Baalbek was built over an even older temple and structure that had 1,000-ton stone monoliths. So, the model is this whole thing of adaptive reuse that civilizations have been building over things not for hundreds or thousands, but for tens of thousands of years. And so a very long-winded answer. That's what Beyond Atlantis is about. It tries to tie this into a more conventional framework for interpreting or understanding these sites.
Awesome. Check out Mark's blog or website. It's beforeatlantis.com. It will be linked below. Go check out his books. You can buy the Kindle. You don't have to get the hard copy. You can get the hard copy. But you can stay tuned to Mark's updates because this is a blog and he posts pretty regularly here on the website. Leah, do you have any final words for Mark before we go?
No, just thank you so much for coming on, Mark. This was a very interesting conversation. I really enjoyed your paper. It spurred on a lot of different things to think about and consider in all of this, and maybe some additional variables I wasn't really thinking about as we try to tease apart the history of Earth and civilization as well.
Well, I hope we can stay in touch. I got a few ideas too. Talking to you guys, it was a great conversation. I appreciate your asking me to be on, and I look forward to connecting again in the future.
It's become clear that the multidisciplinary approach to answering these questions is the only way to go. We appreciate you, Mark. Check out his website, and we'll have another podcast coming up soon.
Thanks, guys.
Have a great night.
You too. Bye-bye. Ciao.
Aaron.